This video is about periodic trends in atomic structure. In today's video, I'm going to talk about ionization energy. Now, this is going to be one of two videos that I'm going to record on this topic. So the second video is going to be on electron affinity. You can check it if you are interested. Ionization energy, by definition, is the energy required to remove an electron from a gaseous atom or ion. Now, where the atom is assumed to be in its ground state. The energy needed to remove the highest energy electron from an atom is the first ionization energy. Now, when we are comparing the ionization energy of two elements, we mainly look at four main factors. The first factor is the distance from nucleus. Now, this means it depends the electron on which energy level. The higher the energy level, the further the distance from the nucleus. Now, the second factor we look at is the shielding effect. This results from the repulsion between the valence electrons or outer electrons and the core electrons or the inner electrons. Now, the higher the number of inner electrons, the stronger the shielding from the nucleus. The third factor we look at is the electron-electron repulsion, and this results only if the electrons are paired in a single orbital. And the last one is the effective nuclear charge, which means how high or how positive is the nuclear charge. So this depends on the number of protons in the nucleus. Now, in general, the ionization energy increases when we go across the period from left to right, and also increases when we go up in a group. Now, let's explain why the first ionization energy generally increases when we go from left to right. So let's discuss the following example. Let's compare the ionization energy of boron and carbon. Now, remember, boron is to the left of carbon. Now, if we remove an electron from each, now we can see that the two electrons are removed from the same energy level, which means they are at the same distance from the nucleus. In terms of shielding, they are shielded by the same number of inner electrons, which are two electrons that they exist on the energy level in n equal 1. Now, they are both unpaired electrons, and therefore there is no electron-electron repulsion in this case. So what makes the difference in the ionization energy? It's the effective nuclear charge. The nuclear charge for carbon is 6+, however the nuclear charge for boron is only 5+. Let's now discuss why the ionization energy decreases when we go down in a group or increases when we go up in a group. So let's consider now boron and aluminum, and remember, aluminum is right below boron in the periodic table. So if we remove two electrons from both, we can see that the two electrons removed are not from the same energy level, because the electron removed from boron is from the energy level n equal 2. However, the electron removed from aluminum is from the energy level n equal 3. So they are not at the same distance from the nucleus. Now, looking at the shielding effect, we can see that boron has only 2 inner electrons. However, aluminum has 10 inner electrons, which will increase or provide more shielding from the nucleus. Now, both electrons are unpaired electrons, so there is no electron-electron repulsion, and the nuclear charge here has not that much of effect. So we have said that in general, the ionization energy increases when we go from left to right. However, this is not always the case, because we have some exceptions. Now, the first exception we are going to discuss is the difference in energy between beryllium and boron and between nitrogen and oxygen. Let's first start discussing why the ionization energy of boron is less than the first ionization energy on beryllium. Now, looking at beryllium and boron, if we remove one electron from each, so we can see that both electrons are removed from the same energy level, and therefore they have the same distance from nucleus. Now, however, if you look at the shielding effect, even though beryllium and boron both have only two inner electrons or core electrons. The two electrons in the 2s orbital in the case of boron do provide some shielding from the nucleus, and therefore the inner electrons in the case of boron are counted as 4 electrons instead of 2, and therefore this makes it easier for us to remove an electron from boron than in the case of beryllium. Now in this case, we don't pay that much attention to the electron-electron repulsion and to the nuclear charge. Let's discuss now the difference in the first ionization energy between nitrogen and oxygen. Now, looking at nitrogen and oxygen, if we remove an electron from each, now looking at the distance, we can say that they have the same distance from nucleus and they are removed from the same energy level, which is n equal 2. Now, for the shielding, we are going to consider only the inner electrons, so 2 for each. However, the electron that's going to be removed from oxygen is a paired electron, and the electron that's going to be removed from nitrogen is an unpaired electron. So the electron-electron repulsion here plays an important role, and therefore it makes it easier to remove an electron from oxygen than removing an electron from nitrogen. Now, the effective nuclear charge will not play that much of a role in here. Now let's discuss the multiple ionization energies. As more electrons are removed from an atom, the second ionization energy increases. Now, not only the second, but the third and the fourth, and so on. So let's take a look on the following example. If we discuss aluminum now, and we remove the first electron from the energy level n equal to 3. Now once this electron is removed, the energy required to remove it is 577.5 kilojoule per mole. Now since this electron is removed, the ratio between electrons and protons will be 12 to 13. Now when we remove a second electron from the same energy level, we notice that the ionization energy increases, and it's almost 3 times, 1810. So this is due to the fact that the nuclear charge is attracting more strongly the electrons, since now 13 protons are attracting 12 electrons. Now if we remove a third electron, we can see that the ionization energy is 2750 kilojoule per mole. This is again due to the decrease in the ratio electrons to protons. Now if we continue removing and we remove a fourth electron, now the fourth electron will be removed from the energy level n equal to 2, which means from a shorter distance from the nucleus, and therefore that's going to require great energy. So we can see that the ionization energy for this electron is 11,580 kilojoule per mole. So there is a great increase in moving from ionization energy 3 to the ionization energy 4, and this is mainly due to removing core electrons, and that are bound much more tightly to the nucleus than the valence electrons. Now this explains why aluminum has an oxidation number of +3. I hope this video was helpful to you, so please like, share, and subscribe, and I'll see you next time.